Sure, 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 sure.
Yeah. So we this is a series of lectures starting at 9 a.m. on Sunday morning for a duration of 1 hour, conducted by SMUITM faculty and SMUITM students with support from alumni on all the subjects which are pertinent for GATE 2027 preparation. Okay. Over to you,
Sure,
Ashwin.
sure.
Thank you for your time spent on this.
Sure, sure. Thank you, sir. Thank you, sir. I will be taking over this. If am I audible, sir?
Yes, you're audible.
Sure, sure, sure. Sir. Good morning, everyone. Welcome to Linear Algebra class for GATE Computer Science Preparation Series, third preparation series, third preparation series. Then this may, this section mentions 14 sections, 50 PIQs, formula sheets, and revision shortcuts. It's exclusively prepared for GATE. The thing is, linear algebra is one of the most scoring mathematics topics in GATE because most of the questions are formula and concept based. So, moving on to introduction to linear algebra. Linear algebra studies vectors, matrices, and linear transformations, where vectors are both direction plus magnitude. Matrices include arrangement of numbers. Linear transformations involves matrix changing vectors. Eigenvalues are special scaling factors. Modern AI, machine learning, graphics, and design data science all use linear algebra. So why it is called linear? Because its equations are linear combinations of variables. As you can see here, these are the definitions of the linear algebra: vectors, matrices, linear maps, eigenanalysis. So what are the applications of these vectors and matrices, linear maps, and eigenanalysis? Its vectors are mainly used in velocity, force, position in space, physics, mainly physics, physics subject. Matrices include image pixels and neural network weights. Matrices are used, whereas linear maps are used if in transformation mainly, where eigenanalysis is eigenvalues tell how much scaling happens in that direction. As
Can
you
you
can
repeat
see,
what is eigenvalues?
eigenvalue is the eigen product of eigenvectors that are direction that remain unchanged after transformation.
Can you tell it in simple words? What is eigenvalue?
Sure, sir.
I am a beginner. If you can tell me what is eigenvalue in simple words, it will help me.
Sure, sure, sure. So eigenvalue is a special number associated with the matrix that tells how much a vector gets stretched or compressed after the transformation.
It's a number which tells how much the matrix gets stretched or compressed after transformation.
Uh, Not matrix, sir. A vector. Vector
Vector.
is like we on that we will put arrow mark like that.
Okay. Yeah. Okay. Proceed,
I
please.
will share in PYQs only. I will share where you can correctly understand and
Okay. Okay.
students also correct.
Okay. Fine.
Okay, then moving on to gate weightage. So linear algebra appears almost every year in GATE with around 4 to 8 marks, where main key topic involves eigenvalue, rank, and system of equations. These three topics contribute nearly 60% of the linear algebra PYQs. You can ask like which topic should beginners prioritize. We should use matrices, determinants, and rank, then eigenvalues. So applications of linear algebra involves machine learning, computer graphics, data science, deep learning, AI deep learning, networks, and optimization. Machine learning, PCA, SVD, gradient descent, neural network weights, and covariance matrices. Machine learning involves the linear algebra. Computer graphics include 3D transformation, rotational matrices, projection, and homogeneous coordinates. In data science, it involves dimensionality reduction, linear regression, feature spaces, and matrix factorization. In deep learning, the linear algebra is applied into weight matrices, backpropagation, and attention mechanisms or transformers. Whereas in networks, it's involved in adjacency matrices, Laplacian matrix, Google PageRank, and network flows. Whereas in optimization of linear algebra applied into linear programming, constraint systems, KKT conditions, and Hessian matrices.
What is KKT condition?
KKT conditions means
You can note it down and tell us in the next class, please.
no. KKT condition is Karush-Kuhn-Tucker conditions. These are the optimization problem with constraint. This helps find maximum value, minimum value, and optimal solution, sir.
Okay. Okay.
And then moving on to this is the GATE PYQ patterns and topic roadmap. You can common questions. I will note it down. You can just screenshot it or note it down. GATE repeatedly asked this same pattern questions. This rank finding and eigenvalues, consistency, and linear independence are the main topics in there. The roadmap is arranged from foundation to advanced topics so that you can prepare accordingly from the basic foundation easy to advanced practice. Moving on to matrices. Which are the foundational form of linear algebra. So a matrix is a rectangular arrangement of numbers in rows and columns. The order is in m cross n. It means m is row and n is columns. Here I is row and j is columns. It is the number of columns. The matrix types involves row matrix. Row means one row. In column matrix involves only one column. Square matrix where both m and n, number of rows and number of columns, will be equal, as you can see here. It's a 3 cross 3 example. In diagonal matrix,
See, why
non-zero
column
only.
matrix is shown like that? 2 colon,
Yes.
4 colon means why?
For space issues, I have done like semicolon, sir. I will
Okay.
remove it.
Okay, fine.
For now, it's you can say you can just relate it to 135 example only. Please ignore
Okay.
the semicolons. Now diagonal matrix involves non-zero only on the main diagonal. This is just a short form. I will share in PYQ how it's represented. In scalar matrix, it involves this form. This is the general form which I am saying. This the Ki and In are general form. If the scalar matrix is not diagonal with same value of k, like in 3 cross 3 example, here 1 is there now. In one in first row, first column, and in 5, in place of 5 there is 1. In that is in second row and second column, and in same goes to 9, where 1 is in third row and third column, there 1. Others can be uh, uh, different elements or 0 0 0, which involves scalar matrix. The diagonal should be equal numbers, like diagonal should contain same elements, 1 1 1, not the 159. Identity matrix is diagonal with all ones, and these others involves 0. So the difference is with the diagonal and scalar matrix is, in diagonal matrix values can differ, but in scalar matrix all diagonal entries are same. Then special matrices involve symmetric matrix, where condition is A is equal to A transform or A traversal. Aij equal to Aji for all I and J. Then goes skew symmetric. A is equal to A minus A transpose, where condition is A ij is equal to minus A ji. Diagonal involves equal to 0. Then comes upper triangular matrix, where Aij equal to 0 for I greater than j, where row number is greater than column numbers. Non-zero entries at or above diagonal.
Ashwin,
And
Ashwin, for all of this, a pictorial representation would have been better.
sure, sir, sure. I
Yeah,
will keep in
sometimes
mind that.
relying only on this AI tool may not be even handwritten pictorial is good actually. Sometimes,
Yeah, sure, sure,
yeah,
sure.
visualization will be easier, right? Okay.
Yeah, yes, yes, yes. I
Yeah,
will include in the
right.
upcoming session. I will include pictorial
Okay.
representation. These are the matrix operations: addition, subtraction, same order required, and these are the properties, various related set properties. Only these properties, and just only. Then transpose involves the properties only. Then key properties table, as you can see here. Then no, yes, yes, yes. Then properties related to it. The common mistake is A into B is equal to B into A is false for most of matrix pairs, because matrices changes when the multiplication order changes. This is the most important property that GATE exam frequently tests.
So what you are saying is A into B is not same as B into A.
Yes, sir. Yes, sir. Yes, sir. Not as same as multiplication, because when the matrix, consider a matrix A, consider matrix B. If that matrix multiplication is one order, if B comes first, it completely changes the values inside that matrix.
Okay.
That's what.
Okay. Welcome to Shravya. Thank you for joining, Shravya. We really appreciate your time on a Sunday. Yeah. Go ahead, Ashwin.
Sure, sure, sure. This is a PYQ. If A is a 3 cross 3 matrix with eigenvalues 1, 2, 3, what is the determinant of A? So determinant of A of any matrix is found by this formula. As you
What
can
is
see
the
here,
symbol there? How do you call that symbol as? Lambda, is it?
it's lambda, yes, lambda, sir,
Is
lambda.
it lambda? Okay.
Yes, sir, lambda, lambda.
Okay.
This property is 1, 2, 1, 2, 3 for shortcut purposes, use this formula 1 into 2 into 3, which comes to 6. Trick is the determinant is equal to product of eigenvalues. Trace is the sum of eigenvalues. Answer 6. The trap is don't add eigenvalues, that gives trace, not determinant. Same goes for these PYQs. It's the formula. Please note it down. If you memorize these formulas, it will be much easier when performing operations in gate exam only. It will save much time of your precious time. So then next question is for matrix A, which of the following is always symmetric? Check for that. Please check each option by applying transpose. This transpose where it involves symmetric, then this involves skew symmetric, then A transpose of transpose is A transpose of transpose into A transpose, A into A transpose, which is symmetric. So both A and C are correct. Like this question they ask, that's why you have to check every option in gate and also apply some formula and shortcuts to ease your time or save your precious time. Apply this transpose, use this as shortcut. Please note it down this further. Moving on to determinants. So determinant represents area or volume scaling. Like it's a square matrix is scalar value that encodes geometric information about the matrix. Determinant A is equal to 0, where it usually represents matrix is singular. 2 cross 2 matrix involves this formula, whereas 3 cross 3 involves cofactor expansion involves this formula. Here minus is there because when while transforming, which involves minus factorization, like this in 2 cross 2 matrix. Then comes the plus combination. Here are the key properties. Please note it down. This will be helpful in gate examination. Next, moving on to PYQ. Evaluate determinant of
Just go back.
1, 2.
Just go back.
Yes, sure.
The last line, first one, determinant of k is equal to k to the power of
Yes,
n. Where is n
yes,
coming?
N.
Only where, n is not there on the left hand side.
Where, sir?
Yeah, what is n here?
Here N is
On the left hand side, I don't see n there.
okay.
Is it correct?
Is correct.
Okay, I don't know much about this, but looks
No,
little
it's
odd.
okay. Sir. I can explain.
Okay, you can check later.
The N means order of the square matrix.
Oh, n is the order, is it?
Yeah, order of the square matrix. This
Okay,
3
okay.
cross 3 is
Uh-huh.
there, na? That is the order of the matrix.
Okay, okay. Yeah.
Where 2 cross 2 means order of matrix is 2. 3
Yeah.
cross 3 means
Understood, understood. Okay, yeah.
then moving on to PYQ section. Evaluate determinant of a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Row concept is involves row reduction determined by operations like this rank. This is the main solution because I will share in PYQ. For explanation, I have done this. First step is row operation involves R2 minus 4R1 to row reduction to make 0 here. Then moves on R3. When you apply the operation, make sure you are applying for both row and both column, you are applying the same condition, not the different condition. Main purpose involves making a one row 0 so that both other two rows are can be solvable in case of equations or in case of finding the determinant. The trick, as mentioned here, a trick is R1 plus R3 is equal to R2. Arithmetic progression rows, determinant row instantly. Please note it down because it will share this lengthy solution. It will reduce that. Here, here the student mistake is don't expand it to all 6 terms. Always check the linear dependence first. Please check this linear dependence, then you can mention. Please note down these formulas also. It's important. The determinant quick revision. This is shortcuts. Please note it down also. For PYQ solution also it's required. Then comes rank of the matrix. So here rank tells the number of linearly, the rank of matrix here tells the number of non-zero rows in row echelon form, which is equal max number of linearly independent rows or columns. Here rank tells the number of linearly independent rows or columns. That its rank tells number of linearly independent rows or columns. Sorry, important formula is rank is equal to number of non-zero rows in reference. So why rows and columns given same rank is row rank and column rank are always equal. As you can see here in 2 cross 2 matrix, in matrices 2 cross 2 and 3 cross 3. Here 2 cross 2 here 2 cross 2 and 3 cross 3 where row column and row rank and column rank will be same. That's why rows and columns are given same rank. These are the elementary row operations as you seen here. This determinant value solving. These are the row operations. This is the methods to find rank are row echelon form, maximal minor method, and normal form. As you can see here, important note is Ri corresponds to Ri plus K into Rj, K Rj. Determinant is unchanged. Only swap and scaling change the determinant. This is the critical mistake that students say that determinant will be changed for this, but only swap and scaling will be changed the determinant. The PYQ. As you can see here, this is the rank of matrix seen here. Answer would be 1. Moving on to system of linear equations. Any doubts so far?
You proceed. For me, I need to revise from beginning, so proceed.
Okay, sir. Okay. So system of linear equations. So this is the Rose-Capelli theorem for this represents for Ax equal to B form augmented matrix A or B, A or B. Let rank A and R star rank AB. Consistency depends on comparison of R and R star. Here R is not equal to R star where no solution involves n slash A, n divided A. R equal to R star equal to N will be consistent. It involves unique solution where R equal to R star less than N, which involve consistent, it will be infinite solution. N minus R will be free variables. The Gauss elimination method. This is the theory. In PYQs, I will provide problems so that you can solve accordingly. The steps involves write augmented matrix and find pivot column, create pivot and eliminate below, and repeat the same for submatrix and back substitution. For homogeneous system, always consistent trivial solution x equal to 0 always exists. Infinite solution exists if and only if rank A is less than n. Is the system of equation P by Q. As you can see here, when solved, R star, where R equal to R star, system is consistent. And also since system 2 less than n is equal to 3, n minus r, one free variable, there are infinitely many solutions are there. The common mistake is r is equal to r star, n would give unique solution. Please check this n carefully. The trick is, please memorize these conditions. Moving on to vector spaces, which involves subspaces, span, basis, dimension, and linear independence. A vector space is a set of two operations, addition, scalar multiplication, satisfying eight axioms: closure, commutativity, associativity, identity, inverse and distributive, and scalar associativity. Here, as you
Wait,
can see,
what is closure?
Closure means what is closure means here. Closure means yes, if you consider vector u, consider vector v, which belongs to set w, then their sum must be also belong to the set. Sir.
Okay.
Here, suspect test three conditions should satisfy. That's when it's called vector space.
Okay.
Then this rank nullity theorem formula should be noted because it's mainly asked in gate solutions. And, moving on to these are the dimension. You can note it down for solving the problems. Moving on to linear independence. Here the core meaning is core definition is no vector should be expressible using others. Uh, it's only linear independent if this C1 V1 plus C2 V2 and plus infinity etc. plus Ck Vk equals 0 implies C1 C2 is equal to 0. Otherwise, it is linearly dependent. The meaning is that constant C1 should equal 0. Then only it's said as linear independent. Otherwise, it's said as dependent. The testing for independence involves form a matrix, find a rank, then determine testing the determinant. For square matrix determinant not equal to 0, it is independent. For functions, if W not equal to 0, involves independent. Here the key factors is any set containing 0 vector is dependent, and a single non-zero vector is independent. N plus 1 vectors in R of n, R to the power of n are always dependent. If one vector is equal to scalar multiple of another, is dependent. When rank is less than number of vectors, it is dependent. A common mistake is 3 vectors in R to the power of 3 can be independent, but the 4 vectors in R to the power of 3 is always dependent. The key threshold is in n plus 1 vectors in R to the power of n. The gate question. The formula is take this determinant of this. When it not equal to 0, it is linearly independent. Then comes eigenvalues and eigenvectors. Here eigenvalues, as you can see, V equal to lambda V. Eigenvector V is a non-zero vector that only gets scaled, not rotated by matrix A, where lambda is eigenvalue, the scaling factor. This is the scaling factor. What direction does this transformation preserve? Please think in that direction. And how to find the eigenvalues is the theory. This is the theory. Set up determinant of A minus lambda I, where lambda I is identity matrix which equal to 0. Expand this determinant. Then solve the polynomial lambda. This when lambda is across to this product, please solve that equation. Then comes the roots, which are eigenvalues. Characteristic poly is determinant of A minus lambda I is equal to 0. This condition you should remember. If you remember this condition, any vector matrix A with that identity matrix, you can involve 0. Identity matrix involves diagonal elements as 1, 1, 1, other elements as 0. These are the essential properties. Please note it down. This is mainly involves in GATE questions and GATE PYQ solution, which will save most of the time. Question is 3 cross 3 matrix A as trace 9 and determinant A 24. Here trace is, as you said here trace. Okay. Here trace is, suppose you consider lambda 1, lambda 2, lambda 3. Its addition are lambda 1 plus lambda 2 plus lambda 3 is called trace. Whereas lambda 1 into lambda 2 into lambda 3 involves that is the lambda transformation, I guess. That's the lambda transformation. It's a trace, yeah, determinant, sorry. Lambda 1, lambda 2, lambda 3 involves determinant. Whereas trace is lambda 1 plus lambda 2 plus lambda 3 is involves trace. Please note down this formula. Based on this formula, you can calculate this 424. Then both conditions satisfied. Lambda 3 is equal to 4. Answer is 4. Third eigenvalue is placed here. Please don't use determinant formula alone. Use trace for direct subtraction. Whenever that trace value is given, please when lambda 2 value find the Ashwin, right? That's the time when you use trace formula, not the determinant formula. Determinant formula makes that things complicated. That's why use trace formula in that condition. Then comes if lambda is an eigenvalue of A, what is the eigenvalue of A square minus 3A plus 2I? Its formula is A is equal to PA equal to A square minus 3A plus 2I. Then eigenvalue will be lambda square minus 3 lambda 3 into lambda plus 2. The solution is, please note down this formula. If AV is equal to lambda V, then A square V plus equal to lambda square V. This is a solution expansion. Then this is the eigenvalue will be lambda square minus 3 lambda plus 2. This is the derivation of that formula. Please note down this formula only. Usually they don't ask derivations and all, but based on this, all problems they will ask. Don't compute A square. The trick is don't compute A square explicitly. Just substitute lambda into the expression. Please substitute lambda into the expression. Then comes diagonalization. The key a matrix when it is said that the matrix is diagonalizable, if A matrix A equal to PD uh, P D and P inverse, where D is diagonal eigenvalues and P is the matrix of eigenvectors. Not all matrices are diagonalizable. The conditions are n distinct diagonalizability is always diagonalizable. Repeated eigenvalues, and defective matrix is not diagonalizable. When repeated eigenvalues there, check geometry multiplication and algebraic multiplication. This condition should be checked. Where symmetric real matrix will be always diagonalizable. Then sorry. There's some issues here. I will correct this. Here the explanation is A transpose equal to A inverse with orthogonal matrices, where rows also form orthogonal basis. So send the corrected material. Then comes inner product spaces. Inner product spaces, this dot product and vector normal form. These are the just conditions. Please remember this. Based on this, I will send these problems and all. This is the PYQs for practice. The formula summary sheet. Please note it down. Complete formula reference and all. These are the shortcuts. These are the common doubts if you are not able to ask and all. The final revision sheet. You should do for these steps to actually master this linear algebra. The time management is read all options first, use shortcuts for speed, verify with properties, and spot the trap first. Spot the critical condition or the common mistakes first. Then rank Q is because if you for time guide is please find rank eigenvalue system which involves time management. Keep and return if If it consumes much more time, skip it and then return after if it is it consumes more time, like 4 minutes or 5 minutes. This concludes gate topics for rank, eigenvalues, consistency, measurements, and independence, and all other linear algebra process. Relevant PYQs and other materials, corrected materials, I will send by today afternoon.